Daniel Zala Bryce Cas Chan Cas Bryce Zala Daniel Zala Bryce Cas Chan Bryce Zala Daniel Zala Bryce Chan Bryce Zala Bryce Chan Zala Daniel Bryce Chandler I meant Chandler Bryce Zella Daniel. Wow. We miss you, Daniel, Zella, Bryce, Cass, and Chandler. Okay, homework questions. What's up? Any of them? Was this one of them? You want to do this one? I don't care. Someone last year wanted this one. I like this one. I don't care. Do we need this one? What do we want? Okay, so I want to add this thing up. This would be adding up n equals 1 to infinity, maybe? 1 over 200n. You guys okay with that? Because if you plug in 1, 200 times 1, 200. 200 times 2, 400. 200 times 3, 600. So that's perfect. Is that the same as this? Can I just pull that 1 over 200 out? Just like you do with integrals. And so if you do that, you have 1 over 200 times that thing. It is a p-series. P-series. P equals 1, so diverge. Start getting used to calling this thing the harmonic series. Because you're going to see it a lot. That 1 over n guy is called the harmonic series, and he diverges. Okay? Goes okay with that one. I think I had some more. Maybe. Okay. Ooh, I like this one. Did we have this one? If not, I don't know. Let's do it. Did you have this one? Cool. Okay. I want to try to do direct comparison with this guy with 1 over n and 1 over n squared. What's 1 over n? Converge or diverge? What about 1 over n squared? Converge. So I don't know which one it's going to be yet, but I'm going to try and compare it to one or the other and see if it works. Okay? So let's look at this. I'm going to build a chart first. N factorial, n squared. Thank you. Big chart. Oh, wasn't a compliment? Okay, so my n's would be actually 1, 2, 3, 4. N factorial would be 1, 2, 6, 24. N squared, 1, 4, 9, 16, 25, 36, 120. Oh, that's getting big. 720, 5, 6. Okay, so I built this chart. Who grows the fastest? Who grows the slowest? So if I wanted to rank them, do you agree I could rank it? Let's see, you just told me n factorial goes the fastest. So he's bigger than, who's the next fastest? N squared, and then n. Okay, so if I want to look at it upside down, I would have, let's see, 1 over n, 1 over n squared, 1 over n factorial. And do you agree the signs would switch? How are you today? Good. Thank you. Thank you. Do you guys agree the signs would switch if you're upside down? Okay. So, in that picture, let's try to compare it to 1 over n. So if you wanted to do it with 1 over n, you'd be going, okay, 1 over n factorial is less than 1 over n. What's this guy do? Diverge. So if he diverges, what can I say about the other guy? Nothing. You guys okay with that? Because in the picture, you would have a diverging guy, and underneath it would be this guy. Could he diverge still? Yes. Could he converge? Yes. I don't know. So you see how that one, the direct comparison test, does not work. What's that? Oh yeah, you could try maybe a limit comparison test. But let me try that. Before I do that, could I do 1 over n squared? Could I try him out? Let's try out 1 over n squared. If I do 1 over n squared, I could go 1 over n factorial is less than 1 over n squared. What does 1 over n squared do? Converge. So what's the other guy do? So then it converges. So do you see how here direct comparison test did not work with 1 over n? It was inconclusive. But here the direct comparison test does work for the 1 over n squared. Okay? And then let's try the limit comparison one. So limit comparison one, you would do limit n goes to infinity. This is the limit comparison test. 1 over n factorial versus 1 over n squared. Is that okay? Why did I choose the 1 over n squared guy instead of the 1 over n guy? Yeah, since we already know the answer. Does it converge or diverge? Converge. So which one do I want to pair it with? The guy that already converges, because I already kind of did the problem. Like, we're done. I'm just trying to practice this way. Let's see if this one works. This would get me limit as n goes to infinity of n squared over n factorial. You already just answered this. Who's more powerful? Roar! N factorial. So if he's more powerful, where does this guy go? To 0. Can you say anything with the limit comparison test if it goes to 0? No. So you guys know how yesterday you guys were saying, do we have to even know the direct comparison test? Can I always just do the limit comparison test? No, because in this limit comparison test, that thing goes to 0, and what did I have to have it go to? It had to go to something. What did it have to go to? A number, positive. Did it have to be positive? I think it said finite positive. Is 0 finite? Is it positive? No. So in this one, because this is a 0, can't determine. So do you see how of all of these things, the limit comparison test failed, the direct comparison test failed with 1 over n, but the direct comparison test worked with 1 over n squared. Do you see how it's kind of nice to have a lot of tools? What's up? Because of our famous chart that you made fun of.
But isn't 1 over n factorial bigger? Oh, okay, so since it's 1 over, then they flip.
So if you look back at my chart thing here, originally right here I said, do we agree with this? And then when I did 1 over them, my signs flipped. Okay, Finn, what's up?
So when you're coming into a problem like this, like when you're doing the examples yesterday, it seemed, it's a little bit confusing for me to know
How to start, how to attack. Yep. I think what will happen is, we'll go over more problems here. It just takes some practice going, especially with the review sets. That's why I love the review sets, because the review sets that I assign are all of the tools at once. And so then you really have to start judging, okay, can I see, divergence sets, geometric series. Today's a really easy one to see. It's called the alternating series one. The limit comparison, direct comparison, it takes a little bit of time to get used to who do I want to compare it to. The one thing I'd say, though, is at first glance, did I do 3 routes pretty quickly? Did I try 3 different ways kind of quickly? 1 over n, 1 over n squared, and then the limit comparison. So they're kind of quick to do. And what you'll get used to is this. When you look at this guy, does he seem to bend? Does n factorial blow up quick? So 1 over it should kind of blow down quick. So in my mind, I bet it converges. So I would not have done the 1 over n. I would have done the 1 over n squared because I'm predicting it converges. So if I predict it converges, I'm probably going to want to use a converging guy. And that's one trick to help you eliminate. If you go, I think this is going to converge, use a converging dude to help you. Okay? What's up? That's kind of probably Finn's question too, of like, how am I doing these things? Normally, you always want to try to go to something that you know. So if you're trying to compare, when you're trying to compare things, so for comparison, turn the page. Please turn it. Okay, there we go. Comparisons. When you compare, you always want to compare with things you know. What's the most basic guys that you know work or don't work? P-series. So if you do comparison, always try to do things you know, which most likely is the P-series. So most likely you're fighting 1 over n's, which diverge, or you're trying 1 over n squareds, which converge. Those are typically the first two I'm always going to go to. Is if I think the guy is going to blow up, I'm going to try and use 1 over n to help me somehow. If I think it's going to converge, I'm probably going to try and use 1 over n squared. Those are my first two attempts that I'll try. So if I ever see things, I'm going to try and simplify it down to checking with one of these two first. Okay. This one. I like this one too. Okay. So let's talk about this one. I want to talk about gut reaction. Do we think it works or do we think it does not work? What do you guys think? Why? Okay. Okay. Break it down now. So this is maybe how I start thinking of things. Okay, let me ask you this way. If I just look at the ln of n on top, good or bad? I want to know, okay, let me look at these. Do you agree I have two components here? I have this guy and I have this piece. So let's just look at this piece. Good or bad? What do you think?
You saying like, yeah, like doesn't converge?
Yeah.
Okay, so like that is
Diverge. What do you think? 1 over n plus 1. What do you think? Bad. Because why? It's like 1 over n, which diverges. This isn't an official test right now. I'm just saying this is my make-believe. This is me trying to do gut stuff. I'd probably still say diverge because it's really basically 1 over n. Okay? You guys okay with that? So then, when I put on, so if I think 1 over n plus 1 is like 1 over n and that diverges, and then I throw that on top of it, does this thing increase? So if that thing increases, let me see if I can draw it with pictures. You might hate the picture version, but I'm looking at this. Okay. I have either this versus, and you might be going, what in the world are you doing, Bach? What graph did I just draw there? 1. So I got 1 over n plus 1. Or I have that thing over n plus 1. You guys okay? It's just the visual picture. How come I didn't keep having this go down? Normally ln keeps going down. Why did I just start it randomly here? Because, yeah, n starts at 1. Do you agree? You just told me this one on the left, this is 1 over n plus 1, which is kind of like 1 over n, which you says diverges. So what do you think the other guy does? Diverges even quicker. Do you agree? Because I don't just have a 1 on top now, I have a number that keeps getting bigger and bigger and bigger on top. In the end, do you agree that thing's going to be infinity, right? On this one over here on the left, I would have 1 over infinity, but that still diverged because it didn't bend down quick enough. Now I have something more powerful on top. I think this guy's going to diverge even quicker. Do you see how? No testing at all yet. I'm just saying, I'm trying to help you with your thought process. Do you guys kind of understand that? Now, if I put here an n squared, I'm kind of confused. Because if I did n squared, do you agree I could look at 1 over n squared plus 1? Is that kind of like 1 over n squared? And that does a what? Converge. But now what do I put on top of that? The ln of n thing. Do you see how that's kind of a powerful thing somewhat? Do you see how now I'm like, ooh, I don't know. I don't know what happens, because now if I put on top of this, woo, a log thing that blows up. Do you see how that's diverging, but I have a converger and I'm fighting wars there. Okay? So, gut reaction, what do you think it's going to do? The original one. And do you agree, like, I want you to really, like, 100% guarantee it's going to diverge. Does 1 over n diverge? Does 1 over n plus 1, should that diverge then? So then this, where I put even more things on top, should make it diverge even quicker. What's up? That's bad. Because, like, 2 wrongs don't make a right. No. If you... no. If you have a converger and he's buddying up with another converger, that's good. If you have a converger that buddies up with a diverger, probably bad. If you have 2 divergers, definitely bad. Better? So is 1 over n a diverger? Is ln of n on top a diverger? So I have a diverger, probably bad. Okay?
I don't know what to say, but if it was, so in our guesstimation,
Mhm.
it's the 1 over n. So it's going to be coming down like this. Having the natural log of n on top, does that kind of hold all of its values up? So it's maybe like the natural function on top of it?
Yeah. 1 over n would look like that. ln of n over n would bend it, try and bend it back up. That ln of n is trying to raise the bar, so it would definitely leak quicker, worse.
Already diverging, and then it leads to convergence.
Yeah.
It still goes to
ln of n, yeah, it still goes to 0. It just pulled it up a little bit before it bent it down. Okay. Okay, just thought process. I'm going to do the work here, but do you guys see why I'm saying that one's a diverger? Okay. Okay, let me try it again. I'll just copy and paste. Okay. We already talked about it kind of being like that guy. Do you agree? Who's bigger? Which one of these is bigger? Left? You guys agree with that? Okay. Let me try a limit comparison test. I'm just going to put one guy on top of the other guy. Let's see. I got 1 over n plus 1, ln of n over n plus 1. Let's see. What does this get me? 1 over ln of n, which goes to what? 0. Can I do limit comparison test? No. So limit comparison, I'm still no idea. Could I try right now, since you told me for sure that one's smaller than the other, could I do direct comparison test? Do we know what this guy does? Have we officially know what this guy does? Yeah, even though our gut's officially telling us it diverges, have I given you a test to tell me it diverges yet? No. Who should I compare this guy to? 1 over n. Who's bigger? Let's see. This is bigger on bottom, so he's smaller. Okay. So let me see if I can just try this picture right here. Can I try this one with direct comparison test? Here we go. Let's try this one. Just right here. He diverges, and he's smaller. Good or bad? Oh.
So if we're going to compare 1 over n plus 1 log of n over n plus 1 at 3, or the 1 over n plus 1 with 1 over n, why don't we just compare 1 over n with that?
Yeah.
Okay. So, great question. So, Finn's question is, I want to compare these directly. Is okay with that? That's kind of his question. He goes, why am I kind of doing an intermediate step? Okay. If I did it with the limit comparison test, I'm going to have, or first off, can I do this with direct comparison? Look at these things. Do they line up the same? No. So do you know who's guaranteed bigger, just sequence-wise? No. So you see, because one's a greater than symbol and one's a less than symbol, I can't do direct comparison tests. I would need them to be this is smaller than this, which is definitely smaller than this. Kind of like, could I do it with this one? The 1 over n, I could compare the 1 over n guy all the way down with this guy because the symbols were the same the whole way through. So on this one, I can't because the symbol changed. So I can't do direct comparison test. You guys okay with that? Let's try Finn's method of the limit comparison test of these. So I got ln of n over n plus 1 all over 1 over n. Let's see. So this goes to n ln of n over n plus 1. You guys okay with that? Do I know what that goes to yet? No. Let me ask you this. Could I do, right now, is this infinity over infinity? You guys agree with that? Okay. Let me ask you this. Could you do Hopital? You can. Okay. So let's do Hopital. The derivative of n is 1. So I got ln of n. I am plus n times 1 over n all over 1. You guys see the Hopital there? I did a product rule on top. What happens? What's that go to? So is that finite and positive? So do you see how good? I love how you said, why don't we just try and do this guy to this guy? Did that work? Because I got infinity. What's the only way I can do it? Limit comparison test works when what? Finite and... So did that one currently work as a test to tell me what I have? No. Let me finish real quick and then I'll answer you guys too. Come back to this black one here. Direct comparison didn't work. What would work? Limit comparison. Could I do limit comparison tests on the black one? I got 1 over n and 1 over n plus 1. So that's n plus 1 over n. What's that go to? 1. So does that work? So those two in that black box both converge or both diverge. So they both what? Both diverge. You guys okay with that? Now can you walk it backwards? So I'll put big letters for these diverges. You obviously diverged. This guy we just found out diverges. So now can you tell me what the blue guy does? Yeah, because in this picture, the red one is here, and he diverged. So what's the blue guy have to do, which is above him? he also diverges. Did we already kind of feel it was a diverge to begin with? Okay. So I'm going to do this one to start the video again on the next video, and I'm going to show you how I would do it very quickly instead of all this kind of mumble jumble that we just talked about. Okay.